Okay, today we're going to do lesson 4.3, but have a bit of a sore throat, so bear with me here. Okay, 4.3 is about using tables and graphs to solve, and it's a really pretty straightforward lesson. Okay, so tables and graphs, which you're familiar with, can be used for comparing values, and when you use them, you can often compare two or more situations. Practice work, which you'll do in class, is 1 through 15 odd. There's a lot of A, B, C, D to it, so it seems like it's only 7 problems, but because of all the different iterations, it adds up. Okay, so here's Miss Lovett again. And you know Miss Lovett, she's got these Twizzlers that she keeps buying and moving around Georgia. Well, this time she wants to buy a whole bunch of Twizzlers, and she wants to buy them online and have them shipped to her. So she finds these two companies. One is called Yummy Tummy, and the other's called Happy Belly, and she's trying to decide who she should buy them from. Well, she looks online and realizes that Yummy Tummy charges $25 for shipping, and then 10 cents for each package of Twizzlers. Happy Belly charges $7 for shipping, and 30 cents for each package of Twizzlers. She's like, who should I buy them from? Well, obviously it depends on how many packages of Twizzlers she's going to buy, because if she only buys 25 packages of Twizzlers, Happy Belly's a better price. They're going to charge her $14.50, and Yummy Tummy's going to charge her $27.50. Well, where did I get those numbers from? Well, I set up an algebraic equation for each of them, where the constant was the shipping price, plus the thing that's varying, the per unit price, times the number that she's going to buy. And then here the constant is lower because the shipping price is lower, but the per unit price of 30 cents was higher, times the number of units that she's going to buy. So I set up the table with those two equations and figured out how many dollars it would be for a certain number of Twizzlers. And like I said, she's better off with Happy Belly if she only wants to buy 25 packages. But if she wants to buy 125 packages, she's actually better off with Yummy Tummy, because they're going to be $37.50 and Happy Belly is going to be $44.50. So she's not really sure how many she wants to buy, because she's going to buy them for her, she's going to buy them for her sisters, she's going to buy them for her mom and dad, and she might even be buying some for us. Okay? So somewhere around here, it switches from Happy Belly being the best place to buy them to Yummy Tummy being the best place to buy them. Okay? But she's not really sure exactly where it gets better to switch from Happy Belly to Yummy Tummy, because we don't have enough data in between those 2 points to figure out where it switches. Well, instead of incrementing by 25 like this table, we can change our table and increment by 5s. Okay? When we do that, we get a much more detailed table, and we can see that right here at 90 packages, it doesn't matter who she buys them from. Yummy Tummy and Happy Belly are the same price at 90 packages of Twizzlers. And that point is called the break-even point. Okay? Break-even point is when it switches from one to the other, and at one point it's better below that point to buy from Happy Belly, and it's better above that point to buy from Yummy Tummy. So that's where it breaks. Okay? So if she wants to buy more than 90 packages, she's going to buy from Yummy Tummy. If she wants to buy less than 90 packages, she's going to buy from Happy Belly. And if she wants 90 packages, it doesn't matter where she buys them from. She could choose either one. Okay, you can take that same information and put it in a graph, where the light colored blue down here is the Happy Belly part of the graph. And you can see down here, Happy Belly is less than Yummy Tummy. But right here at 90, it switches, and Happy Belly starts becoming greater than Yummy Tummy. okay? So again, 90 is our break-even point. And any purchases above 90, she'd be better off buying from Yummy Tummy, because Yummy Tummy is now lower than Happy Belly. Okay, so the advantages of tables versus graphs is what this next thing talks about, and this is the last paragraph in your lesson in your book. It says, when would you want to use a table? When would you want to use a graph? When would you want to use an equation? What's the advantage of each of these things? Well, if you have lots of data to display, a table or a graph can solve that problem for you. Both of them can display lots of data. And both of them can let you compare data, just like we did on the various columns and we did on looking at the graph. The thing that a graph does that a table doesn't do is a graph shows you the trend, whether it's going up or down or up and then down. Tables don't do that as well. The thing that a table does that a graph doesn't do is provide lots of details. You can make a table be very, very detailed, and it's hard to get that kind of detail in a graph. The disadvantages of them could be that if you have lots of data to calculate, tables and graphs may be rather time-consuming to create, and if you have a calculator or a computer, less so. And they might not be able to determine an exact solution, because you might have to go into detail and detail and detail and detail further and further and further and still not get an exact solution because of just the way the data is. But a equation does let you get the exact solution for a particular situation, okay? And that's an equation whether it be for an equality or whether it be for an inequality, okay? The table lets you see, the equation lets you see the exact solutions. And that's basically what 4.3 is about.